I'll right-click on my Detect Enemy node and select Edit Custom Action. Custom actions operate in 3 steps. A start method is called one time before the action is executed. This is where resources are allocated and variables are initialized. Execute is then called repeatedly once per frame until the action completes or is stopped. The stop method is always called after an action finishes execution to allow any allocated resources to be released. The reason we're using a custom action instead of a regular detect node is that we'd like to detect only objects in the scene that are not associated with our own team. To do that, we need to use the sensor to look for a team aspect, then compare it to the AI's team. We'll want to find the nearest object on another team and assign it as the enemy. Notice here in our variable definitions we have a public rain expression called enemy variable. When custom actions use public expressions, they become visible and editable in the behavior tree editor. Enemy variable is used to let you specify what variable you want to use to store the enemy game object that is detected in this action. The start method is used to locate the team element on the AI. The team element is covered in more detail in another tutorial, so I won't go into detail here, except to say that it's used to determine which team our AI is assigned to. We also evaluate the enemy variable expression here in start, and record the name of the variable we'll assign our results to. The execute method starts by requesting a list of all aspects with the aspect name team that are currently detected by sensors named visual sensor. We then check each matching aspect one by one, making sure that the aspect is actually a team aspect. Team aspects are custom aspects we've defined for this project that carry information about which team an AI or player is on. Here, the code looks for aspects associated with another team, those are the enemies, and keeps track of the closest one. Also notice that the code checks to see if it already has an enemy assigned from a prior execution. If it does, and if that enemy is still detected, then it will prefer that enemy over all the others. Once we've located our nearest enemy, the code assigns the enemy game object into AI memory associated with the enemy variable. Okay, that pretty much covers how enemies are detected and how enemy positions are stored for our soldier. Now let's go back and look at the patrol behavior.